video, we will be looking at the graphs of the functions sine and cosine, which are periodic functions, meaning that they are repeating themselves over time. We saw in the unit circle that as we move around to angles that are in the same position, coterminal angles, we get the same sine and cosine values. And we're going to translate that information into graphing. As I mentioned, these are considered periodic functions, things that are repeated over a certain period of time. This graph is representing a heartbeat. Probably you've seen this if you've been in a doctor's office or hospital. And you can see that the period in this case is where we can look at a particular part of the graph that has a similar characteristic, like this little minimum point here, this little minimum point here. And so the distance between each of these minimum points would be the same. And that's what we would call the period. How long it is before a particular portion of the graph to repeat itself. A periodic function mathematically is defined as something that will be repeated when we take an existing input value, x in this case, and we add a certain number of the periods to it. The value p is in the place of whatever the period is, how long it is until the graph repeats, and n is an integer. It's an integer meaning a whole number, such as plus or minus 1, plus or minus 2, plus or minus 3, etc. For our purposes, that value n is going to represent, if it was a positive one, it would represent going around the circle one time in a counterclockwise fashion. If it was negative one, it would represent going around the circle one time in a negative fashion. Plus 2 would be going around the circle twice. Minus 2 would be going around the circle twice in the opposite direction. And so we're just saying that we're ending up at the same location each time. Because the circumference of the unit circle, or that distance all the way around one full rotation, is 2 pi, that's what we are going to consider the period to be for both the sine and the cosine graphs. So if I were to look at the sine of a particular value, let's say the sine of, let's look at pi over 3. The coordinates for pi over 3 are 1/2 and the square root of 3 over 2. Again, this is going to be the cosine value, and this is going to be the sine value. Add 2 pi to that number. Let's think about pi over 3 plus 2 pi, or pi over 3 plus, let's put this as 6 pi over 3. I'm making them the same denominator. This is 7 pi over 3. That's representing the angle that starts here, goes all the way around the circle, and then ends in this same location. This would be 7 pi over 3. They're in the same location, and so they have the same sine and cosine values. That same thing would happen if I went around the circle twice or 3 times. It would also happen if we went in the opposite direction. What if we took pi over 3 and we subtracted 2 pi? That would give us negative 5 pi over 3. So negative 5 pi over 3 is also in this location. And they all are going to have the same sine and cosine value. So when I look at these two functions, this is saying if I take the original angle that I started at and add some multiple of 2 pi, the cosine values will be the same. Similar for the sine values. This is a little bit of information that helps us understand what the graphs look like. I'm going to draw a couple pictures let's talk about the sine value first. Let's talk about the sine value first. Let's talk about sine of s. And this will be 0. This is pi over 2. This is pi. And this is 3 pi over 2. And then we'll come back around to 2 pi. All right. This first part here is saying that as I go from 0 to pi over 2, the sine is going to increase from 0 to 1. So if I think about a triangle, and the sine is the y-coordinate, right? This value or this value. Yeah, I can see that the sine is increasing, right? It starts at 0 and it's going up to a maximum value of 1. And then if I go in this area, in this region, which is going from pi over 2 to pi, now I'm looking over here at a couple of triangles. Again, looking at the y value. The y value is this. The y value is decreasing. It's up here, it's at its maximum at 1, and it goes down to its minimum at 0. These values are going to be going in the opposite direction when I look at the cosine, because cosine is the y-coordinate, or sorry, the x-coordinate. So for cosine, when I'm going between, say, 0 and pi over 2, the cosine value is going from here and maybe here and down, right? It's going from 1 at its maximum down to 0 at its minimum. So cosine is measuring these values. You can see that they're decreasing, whereas sine is measuring these values, and we can see that they're increasing. And that's going to change for each of the 4 quadrants. But this gives us an idea of how the graph looks. So for the sine, let's draw a circle here again. Again, the sine is the y values. So when I'm in the first quadrant, the y values start at 0. I can see that I start at 0. And then the y values are going to increase until they get to 1 when I'm at pi over 2. So at pi over 2, I see that the y value is 1. And the values I see are increasing. When I go around through the second quadrant, those y values are decreasing from 1 down to 0. So that's this portion of the graph. Decreasing from 1 down to 0. In the third quadrant, I'm going from 0 down to -1. Again, talking about the y-coordinate for that portion. And then I go from -1 back to 0 as I go around here. And then the graph will repeat. The graph is going to repeat that same idea here. You can see over on the left-hand side, there's a different portion of the graph where it's repeated. And it's going to continue on endlessly. Let's look at a couple features of the sine graph. It's going to be continuous. There aren't any holes or breaks in it. Its domain is going from -infinity to +infinity. As a reminder, the domain is what all the x values are that it touches. So if I took the graph and I brought it down to or up to the x-axis, what x values would it touch? And it's going to touch all of them from -infinity to +infinity. The range, on the other hand, is the set of all the y values. So if I took the graph and I put it onto the y-axis, it looks like it's only going to go between -1 and 1. So that's called the range. The x-intercepts, or where the graph is crossing the x-axis, I can see they're showing up at -2 pi, -pi, 0, pi, 2 pi, and so on. It's pi multiplied by an integer. And again, we use that integer n to denote, or the letter n to denote an integer. So that's where all of the x-intercepts will show up. The period is 2 pi. That means that if I take any 2 points that are in the same location, such as this point here, where the graph starts to go up, and then this point here, where the graph is going to start to go up again, the distance between those 2 points is 2 times pi. We're not considering this part, even though it's at 0 again, because the graph is decreasing at that point. It's starting to move down. We want the points to be in the exact same position where the graph starts to increase again. And the last thing for us to look at is the symmetry of the graph. It's symmetric with respect to the origin. What that means is that if I took a particular point on the graph, let's say this one, and I rotated it around the origin 180 degrees, I would end up here, right? It goes from positive to negative, and it's reflected across the y-axis. And so this is the way that we write that mathematically. When you plug in a negative angle, you get the opposite sign, S-I-G-N, of the output value. Cosine is similar, except it starts at a different point, because with cosine we're starting at a maximum value. So for cosine, we're starting at a maximum value here. We're going down to the center. We go down to a minimum value, back to the center, and then up to a maximum point again. And then it will repeat. Again, this graph is going to continue, go down to the center, minimum, center, and so on. This is the pattern that cosine will always follow. Let's look back for a second at the sine graph and look at what the pattern is for that. The pattern for the sine graph is different. It starts at the center, goes up to a max, back to the center, down to a minimum point, and then back to the center. I bring this pattern up because this is a pattern that we'll use to graph sine and cosine. Many of the characteristics that we had for the sine graph are the same for the cosine graph, such as the domain and the range and the period. As far as symmetry is concerned, this graph has a different characteristic, that it is symmetric about the y-axis. So if I look at a point on the right of the y-axis and the left, they're identical, right? I could fold it in half on the y-axis and it's a mirror image of itself. As far as the intercepts, the x-intercepts, let's see where they are. Here, 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 here. It looks like they are all at fractions where the denominator is 2. So that's where we're getting this pi over 2. And they're going to be at odd numbers. The next one is going to be 5 pi over 2. And then the next one would be 7 pi over 2. This is a format that we use to denote an odd number. An odd number is always going to be one more than an even number. So let's see what happens. If I plug in n equals 0, then 2n plus 1 is going to be 1. And if n equals 1, 2n plus 1 is going to be 3, and so on. And I'll get 5 and 7. I can also plug in negative numbers. What if n is -1? then I'm going to get -2 plus 1, that'll be -1, right? So this is just a way that we denote odd numbers. All right. The amplitude is a different way of talking about the maximum and the minimum points of a sine or a cosine graph. And it comes from the number that is multiplied in front of the function. So we use the letter A for amplitude. Now, if that happens to be a negative number, we take the absolute value because that max and min is still going to be at that same point. But a negative sign means something different in the graph, and we'll go through one of those in a second. But the center of the graph is going to be halfway between the top maximum and the minimum, and so the amplitude is going to go from the center. So for example, let's suppose that we had y equals 5 cosine of x. The amplitude is going to be 5. And so if we have the x-axis as the center, so this would be the line y equals 0, our maximum point is going to be up at y equals 5, and our minimum point is going to be down at y equals -5. So the amplitude isn't the distance between the max and the min, it's the distance from the center to the max and from the center to the min. All right, so here's an example of a graph. We are going to use 5 points for a standard process for graphing sine and cosine. We're always going to start at 0, and then we'll go to the end of the period, which in this case is 2 pi, because we haven't made any changes in the period yet. We'll split that in half. If I split the distance between 0 and 2 pi in half, I get pi. And then I'll split each of these in half, but the halfway point between 0 and pi is pi over 2. The halfway point between pi over 2 and 2 pi is 3 pi over 2. Let's talk about this one for a second. How do I get that number? What you're doing is you're finding the midpoint. You find the midpoint by adding the two numbers together and dividing by 2. So to find the midpoint between pi and 2 pi, I'm going to add them together and divide by 2. That's averaging them. So that's why I'm getting 3 pi over 2. We said that the pattern for sine was to start at the center, go to the max, back to the center, down to the min, and then back to the center. The max and the min for normal sine is 1 and -1. But because in this example we have a 2 in front, the amplitude is 2, our max and min points are going to be stretched to 2 and -2. Notice that the center points don't change, right? The places where we're at the center stay at 0. They don't change. So the graphs that I have below, the red one is the original graph of sine of x, and the second one is 2 times sine of x. The only places where we have changes are at the max and the min points. Those max and min points got stretched from 1 to positive to 2 and from -1 to -2. All of the center values, which are on the x-axis, are in the same location. Here for both graphs, right? All of the x-intercepts are in the same location. The period of the graph changes when we put a number next to the place where we plug in the angle. And the period will change by taking the original period, which is 2 pi, and dividing it by that number b. So for an example, suppose that I had sine of 3 x. The period of this is going to be 2 pi, which is the normal period, divided by that number 3. Suppose I had the cosine of 1/5 x. The new period of that is going to be 2 pi divided by 1/5. When you divide by a fraction, it's the same as multiplying by the reciprocal. So the period here is going to be 10 pi. When I graph, I always start at 0. I go out to the end of the period, split that in half, and then split that in half again, split that in half again, right? So that's how I'm going to set all of these up, is I'm going to figure out what the period is, start at 0, go to the end of the period, go halfway, and then go halfway between these 2 points, halfway between these 2 points to get these, what we call quarter points. All right, let's go through one. Here is an example of sine of 2x. For sine of 2x, the period, we take the normal period for sine, which is 2 pi, and we divide it by the number that's multiplied by near the angle. So we're dividing it by 2. So the period is going to be pi. So we're starting at 0, and then we're going to pi. We split that in half to get pi over 2. We split this region in half. Between 0 and pi over 2, the halfway point is going to be between 0 and 1/2. The halfway point is 1/4. So that's how we're getting pi over 4 here. And then the halfway point between pi, or 1, and 1/2 is 3/4. So we're getting this 3 pi over 4, right? You can see that in between each of the elements, it's 1/4. I'm adding a 4th here. I'm adding a 4th, a 4th. So here, this is the same as 4 pi over 4. So I added a 4th to get 5 pi over 4. This is 6 pi over 4, 7 pi over 4, 8 pi over 4. They're just fractions that have been simplified. The pattern for sine is to start at the center, go to the max, back to the center, min, center, max, and then we repeat center, min, center. We're just repeating that pattern. And so anytime that we have center, we're going to be at the x-axis or at 0. Whenever we're at a max, we're at 1. And whenever we're at a min, we're at -1. So then I can plot these values and I can get a graph. Looking at the second one, sine of 4x, the period is going to be 2 pi, the normal period for sine, divided by 4, which is pi over 2. So we start at 0, and then we go to pi over 2. The halfway point is in between them, which is at pi over 4. Then I'm going to add these two numbers together. In your calculator, you can add 0 plus 1/4. Don't include the pi symbol because it'll mess it up. It'll change everything to decimal. Hit enter, and then hit divided by 2, and you should get 1/8. That's how I'm getting this point in the center here. Then what I'll do is go from pi over 4. I'm going to add these two numbers together, add 1/4 plus 1/2, hit enter, and then divide by 2. And you should get this 3, you'll get 3/8, and you'll put the pi symbol in there. So that's how you can find each of those values. Again, we follow the pattern, center, max, center, min, and so we're getting the 0s and the 1s and the -1s. So here's a graph of sine of 2x. That's the first one that we had. Notice that the original, we said that the period for sine of 2x was pi. So if I go from the center part where it's increasing to the center where it starts to increase again, I can see that the distance between these two is pi, as opposed to the original graph, which goes from 0 all the way to here. That distance is 2 pi. I'm looking at the red graph now, right? When I look at the red graph, before it starts to repeat again, that distance is 2 pi. So this is changing the frequency, right? I have waves more frequently when I have a number that's multiplied in front there. Let's graph 2 pi over cosine of 2/3 pi, or 2/3 x, sorry. I'm going to follow the pattern, the strategy that we do. All right, first we're going to find the period. The period is going to be 2 pi divided by 2/3. I take the original period for cosine, which is normally 2 pi, and I divide it by that fraction. I'm going to take 2 pi and multiply by the reciprocal. So this ends up being 3 pi. Okay, that's my period. So we're going to make a chart for the x and the y values. We're going to start at 0 and then go to the end of the period, which is going to be 3 pi. The halfway point here is going to be 1.5 pi, right? 1.5. We would instead call that 3/2. We use fractions in trigonometry. 3 pi over 2. All right, now I've got to find the halfway point between these two. So I add them together, 0 plus 3 halves, and then I'm going to divide that by 2. So that'll be 3 halves times 1/2, which is 3/4. This is going to be 3 pi over 4. All right, and then I will find the halfway point between the last two, between this and this. So I'm going to add 3 halves plus 3, and then divide by 2. Again, you can just do this in the calculator. Use the fraction button because it'll keep everything in fraction form for you. And I'm getting 9 pi over 4. All right. The pattern for cosine is to start at the maximum point, go to the center, minimum, center, maximum. That's the pattern we'll always follow for cosine. The maximum is always going to be at 1 and -1 and -1 for the minimum. We don't have any change in the amplitude, right? There's no number that's multiplied in front of cosine, so there's no change in the amplitude. And the center is going to be at 0. So you can see these are the points we're going to graph, and you can see them on the graph over here. We're going to have the point 0, 1, 3 pi over 4, comma 0. I'm taking this column and this column and putting them together in coordinates. 3 pi over 2, -1. 9 pi over 4, 0. And then 3 pi, comma 1. I know that you'll be using Desmos to get a lot of these graphs, but you're going to have to show me some of this algebra behind the scenes of how you got these 5 key points, and you can see them reflected on this graph here. Here are the steps that you'll use to graph sine or cosine. First, we figure out what the period is, and then we break the interval into 4 parts, finding the 5 key points. And I've listed out here the patterns that each of the sine and the cosine graphs follow, and you want to memorize those. Once we plot these points, the center points are going to be, in this case, on the axis. Eventually they'll be shifted. And then the amplitude will help us plot where the max and the min points are. And then if you need to smooth out the graph, you can always plug in some more points into a calculator to kind of fill everything in. Let's do one last example. In this example, we have both an amplitude change and a period change. We've got two things happening. We said that the amplitude is going to be the absolute value. So the amplitude for this is going to be 2. That means that our max and our min values will be at 2. I can see that reflected in the graph down here. The negative sign that's in front actually means a reflection. This is going to reflect the graph over the x-axis. Anytime that there's a negative sign in front of a function, that's always a reflection. We also have a change in the frequency, and that is 3. So the period for this graph is going to be 2 pi over 3. So let's put this information together to make a chart of x and y values. We're always starting at 0, and then we'll go to the end of the period, which is 2 pi over 3. We'll split that in half. Halfway point would be pi over 3, right? Then we find the quarter points. The halfway point between this is going to be pi over 6. What I'm doing is just taking 1/3 and dividing it in half, and that would be 1/6. And then we find the other quarter point, adding pi over 3 plus 2 pi over 3. Let's do this over here on the side. We're going to do 1/3 plus 2/3 divided by 2. So I'm ending up getting 1 in the numerator, right, over 2. So that's pi over 2 here. Okay. Now, normally, cosine goes from the max to the center. Min, oh, sorry, this is sine. My bad, sorry. Sine starts at the center, max, center, min, center. This is what normally happens. But because we have a reflection, all of the max and min points are going to interchange. The center points will stay the same. This will change to a minimum, and this will change to a maximum. So now we just fill in our y values. Anywhere that there's a center, that's going to be at 0. Minimums are going to be at, in this case, -2. Don't forget that we've changed the amplitude, and maximum is going to be at +2. So the points that I'm plotting are 0, 0, pi over 6, -2, pi over 3, 0, pi over 2, 2, and 2 pi over 3, 0. Again, I'm looking at the x values that I found from splitting the period up into 4 chunks, and then the final y coordinates that I found by figuring out what the pattern is that it's following. And you can see that I get this graph over here on the left. All right, I have one more sort of challenging example. This one's a cosine graph. Similar to the last example, it has a reflection, right? This negative sign means a reflection. Reflect across the x-axis. The amplitude is 3. That comes from the number, the absolute value of the number that's in front there. But what's the period for this graph? It's interesting. There's a pi there. It's not normal. The period will be, the normal period for cosine is 2 pi, and I divide by whatever number I see sitting next to the angle there. 2 pi over pi, which is just 2. Okay, so I'm going to start at 0, and go to 2, the halfway point will be 1. If I find the halfway point between 0 and 1, that'll be 1/2. And then the halfway point between 1 and 2 is 1.5, or we would write that as 3/2. Notice that there's no pi's in this in these x-coordinates because the pi's canceled here. Pi is a number, so it can be multiplied by the angle there. It's 3.14, yada, 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 but it is a number, and so it can be there. All right, what's the normal pattern for cosine? Typically, we start at the max, center, min, center, max. But because of the reflections, the max and the min points are going to change. They're going to be interchanged. All of the center points will stay the same. So anywhere we have a center point, we're at 0. Our max and our min points will come from the amplitude. So max will be 3 and min will be -3. So the points that I'm going to plot are 0, -3. Again, looking at the x values that I found by breaking up the period, and then the y values that I found by thinking of the pattern of cosine, taking the amplitude into account. 1/2, 0, 1, 3, 3/2, 0, and 2, -3. So those are the 5 key points, and you can see those reflected in the graph here on the left. All right, thank you for watching. We'll go over more examples in class on Tuesday. Have a great day.